So in this class we will learn about dienes. In previous classes we have seen alkenes. Alkenes are compounds having double bonds. So here we are saying dienes. We know that diene means compound organic compounds having double bonds are named as enes. When there are two double bonds, they are called dienes. Now, dienes are classified into three types. Isolated dienes means double bonds are separated by more than one single bond. That means here one at one place it is there, 2, 3, and 4. First, here it is here 1, 2, 3, 4, 5 after fifth. Somewhere double bonds are separated somewhere between the single bonds. They are called isolated dienes. Next, we have cumulated dienes. If double bonds are present at adjacent carbon atoms between successive carbon atom, it is called cumulated dienes. This is 1, 2 propadiene. This is called allylene. 1, 2, 3. 3 means propene. Propene diene. 1, 2 propadiene. It is called allylene. So you see 1, 2, 3, 4 but. 1, 2 butadiene. 1, 2 butadiene. It is called methyl allylene. So conjugated dienes are called alleles. Remember. Next you have conjugated dienes. Conjugate means one after the other, alternate. If double bonds are present on alternate carbon atoms, double bonds are separated by single bond. That means double bonds are present on alternate carbon atoms. This is called conjugated dienes. Hence, dienes are the compounds which have two double bonds. Two, di means two, triene, three double bonds. So dienes are the compounds which are having two double bonds, and dienes can be divided into three types. Isolated dienes, cumulated dienes, conjugated dienes. Remember first basically, isolated dienes we have double bonds separated by a even number 1, 2, 3, 4, 5. That means somewhere isolated. Cumulative means exactly after next carbon. And conjugated means it is separated by one single bond, alternate. So that is called conjugated dienes. So isolated dienes, cumulated dienes, and conjugated dienes. Next, allylene, I told you, the propene, if propene has two double bond, 1, 2 propadiene, it is called allylene. See the structure. Each carbon will be in sp2 hybridization. sp2 hybridization. Here, carbon has one vacant sp2 orbital, p orbital. Here, one carbon it is having two p orbitals. So it is surrounded by the pi electron cloud. Here, 1,3-butadiene, it's a conjugated diene. 1,3-butadiene. 1, 2, 3, 4. So here double bonds can be transferred here if bond polarization takes place. Pi bond breaks. So here positive charge and this carbon gains negative charge. Or it can be shown like this, negative this side and positive this side. These three structures are known as resonance structures. So this is the stable. Dipole is more stable. Separation of charges. Here you can see each carbon is at sp2 hybridization, sp2 hybridized state. So these two overlap and these two overlap, or they can overlap like this center one overlap with vacant p orbital red. They are shown in red vacant. Now the pi bond extends to over the chain of this compound. So the 1,3-butadiene has this resonance structures, and because of the pi electron cloud which is spread over and below the chain, it makes conjugated diene or 1,3-butadiene stable. Next, we can see methods of preparation of. I have in one slide. I want to show you this in one slide only. This is 1,3-butadiene. How are we preparing? 1, 2, 3, 4. 1,3-dichlorobutane. 1,3-dichlorobutane, when it is heated with alcoholic KOH, dehydrohalogenation takes place. Hydrogen from this carbon, halogen from this carbon, here hydrogen from this carbon, halogen from this carbon takes place, and you get 1,3-butadiene. Similarly, if 1,4-butane diol, when it is heated with concentrated sulfuric acid, water molecule is removed from here, and another water molecule is removed from 1,2 carbon and 3,4 carbon, and you get a double bond. Or when butane, N-butane, when it is heated in presence of alumina or chromium dioxide, you get butene. Or you just see here, this is hexene. When it is heated, you are getting 1,3-butadiene. Similarly, if butane is heated in presence of nickel phosphate or calcium phosphate, you are getting 1,3-butadiene. So in methods of preparation, you write separately. 1, 2, 3, 4, 5 reactions I am giving here. You write them separately. Like when number 1, from dehydration of diols. When 1,4-butane diol is heated with concentrated sulfuric acid, you are getting 1,3-butadiene. Similarly, when butane is heated with 1 minute. When butane is heated with in presence of alumina or chromium oxide, what are you getting? You are getting 1,3-butadiene. Next, when cyclohexene is heated, you are getting 1,3-butadiene. So you can write them in separately, 5 types of reactions. Then chemical reactions of dienes. This is also important. Dienes means they are having 2 bonds, 1 and 3. 1 and 3 double bond. When bromine is added, there are different types of. Each is in sp2 hybridization. One bromine molecule is added here. Another bromine molecule is added here. So you are getting 4 bromine added product. Or only 1 bromine is added. See the difference. If bromine is in excess, bromine adds to all carbon atoms. But when bromine is in not so excess or less excess, what you have bromine added on the first 1, 2 carbon, or it is added on 1, 4 carbon. So there are 2 types of additions, 1, 2 addition and 1, 4 addition. This is important here. We want to show here 1, 4 addition and 1, 2 addition. Addition takes place at 1 and 2 carbon, or 1 and this 3 carbon. So 4 carbon, what happens here? We are seeing mechanism. First we will see mechanism of 1, 2 addition. Here you see this bond breaks, bromine, and here we are getting positive charge and bromine is attached here. Next bromine attacks here. Charge polarization takes place. This is 1, 2 addition. Or if the second bromine is attacked on the first carbon, it is called 1, 4 addition. So in one chart only, I wanted to show you 1, 2 addition and 1, 4 addition. Addition of halogen acids, HCl, HBr, HI. So when it is added, you can have 1, 2 addition, 1, 3 addition. 1, 2 means you are getting 3 chlorobutane. 1 or 2. Here 1, 2, 3, 4. 3 chloro, 1 butene. Or it is a 1 chloro 2 butane. Whatever may be the bond. 1, 3 addition and 1, 2 addition and 1, 4 addition. Next mechanism we want to show. First, one bond is polarized by what happens? Positive means electrophilic addition is taking place. It is getting positive. H plus is added here. H plus is an electrophile. It is added here. And it is transferred here. You see, charge is transferred. Polarization transfers. And here, if another Cl minus is attacking on the first carbon, or it may attack on the second carbon. You just see. It may attack here, like this or this. So this is 1, 4 and this is 1, 2. You have to show this. What happens here? Affect how, which addition takes place, whether it is 1, 2 addition or 1, 4 addition. Two products we are getting. At low temperature, we are getting 1, 2 addition. At high temperature, we are getting 1, 4 additions. So 1, 4 addition is favored at high temperature and 1, 2 addition is favored at low temperature, that in case of butadiene. So exact leading to 1, 2 addition product is less than leading to 1, 4 addition product. At low temperature, 1, 2 addition is less, 1, 4 addition is high. Similarly, both addition product and ionization, all these things. So remember, at low temperature, 1, 2 addition. At high temperature, 1, 4 addition is taking place. At lower temperature and higher temperature, that is affected by temperature. Next, free radical. That is electrophilic addition, and free radical means in the presence of peroxides. We have again two types, 1, 2 addition and 1, 4 addition. Here mechanism is shown, radical plus this peroxide effect. You can note down that. This is an important reaction of 1,3-butadiene, Diel-Alders reaction. Diels-Alder reaction, addition of a diene to an enophile, that means ethylene. Dienophile, this is diene. 1,3-butadiene reacts, adds to ethylene. You see here bonds are added. This bond goes this side and this bond comes here. We get cyclization takes place, cyclohexane. This reaction is known as Diel-Alder reaction. Diel-Alder reaction is very important reaction. The addition takes place at 4th and 2nd carbon, you see here. So we are getting a cyclo product. This diene and enophile. This is diene and this is enophile, means compound having double bond. If in place of hydrogen there may be another compound, you are getting that compound. So this is Diels-Alder reaction. It's an important reaction for 1,3-butadiene. Diels-Alder reaction takes place very readily when substituted alkenes containing electron withdrawing groups are used as enophiles. Suppose if you have this compound, electron withdrawing groups, CHO group, acrolein, malic anhydride. So what you are doing? You are getting this substituted product. If electron dienophile means diene, if electron withdrawing groups are present, what happens here? You are getting this compound. And electron releasing groups are present here. 1,3-butadiene, substituted butadiene. Repeated one. Next, so these are some facts which we have to learn with the dienes. So what are dienes? Dienes are the compounds which have two double bonds, and there are three types of dienes: isolated dienes, cumulated dienes, and conjugated dienes. Isolated dienes means here and there will be double bond. The conjugated diene, double bond on the next carbon atom. They are called alleles. 1,3-butadiene is an example of conjugated diene, and you have this resonance hybrid structure of 1,3-butadiene. Preparation, there are 5 methods of preparation: dehydration, dehydrohalogenation, or just heating alkane. The types of reaction, it undergoes 1, 2 addition and 1, 4 addition, and different conditions these additions are taking place. Then there is an example for 1, 4 addition, that is called Diel-Alder reaction. Diel-Alder reaction, here diene reacts with enophile, we get a cyclic compound. Cyclization takes place. That is called this reaction. So what we have learned here is dienes, preparation and properties.